just for transition between the two videos and to kind of get us all back on the same page. And you should not be working on your LRAM right now. That should be blatantly obvious because we're on Chapter 8 now. You might want to actually focus on Chapter 8. So clearly you won't be doing those corrections in front of me because we have better things to do, like the current stuff. So I believe we discussed the fact, what did I say? Maybe I'll flip it around on you. What was, and I was pointing it out where you should have been pointing it out. Why is this function, which was y equals sine 3x, right? 6 sine. I left the coefficient off. All right. So we had y equals 6 sine 3t. Right? All right. So let's forget about what we just did in terms of updating our chart there to pick up where we left off. Because y'all are looking at yesterday's notes, right? Talk to me about this function if you had to graph it. Or maybe we'll just make it a pop quiz if you don't talk to me about it.
When we talked yesterday about how it shrunk.
What makes it shrink and by how much?
3 on the inside.
So 3 on the inside. And so specifically, what would that do to my graph? It pulls it towards the y-axis so that I would, in essence, get 3 periods where I would normally get 1 from 0 to 2 pi. Does that make sense? So how does that help you think about what we want to know here? What do we want to know? We want to know where the graph is increasing and decreasing, right? And why are we using the function they gave us directly? Because what does this graph, or what does this function actually represent? Velocity, right? You with me? So we're all back on the same page? All right. So now, this is not relevant to the specific question at hand, but what would the 6 do? Stretch it vertically, right? So it stretches it away from the x-axis and towards the y-axis, right? Does that help you? The more you can think that way, the easier it will be to fill in these charts. And you don't have to show the work on the AP exam as to why you put a little plus sign where it's increasing, or why you put a little minus sign where it's decreasing. If you have to justify it, you would just put your chart there and say, since v of t is greater than 0 from 0 to 3 pi, or pi thirds, but you don't have to say, this is how I did it. You don't have to show all that stuff we wrote yesterday about where the angles are equal to 0 and all that. You don't have that. None of that has to be shown. Are you with me? So if I can think about this in terms of function transformations, I can save myself from all that. I can go straight to my chart and draw it. Right? So just take a couple seconds every time and try to think it through that way. All right, so let's translate this into an answer to the question. Determine when the particle is moving to the right, to the left, and stopped.
So it's moving to the right.
Okay, so the particle moves right on what interval? 0 to pi thirds. And then what happens?
Well, it changes direction.
It stops, doesn't it? How do I know it stops? And I don't mean like the car that ran the red light in front of me this morning. It actually stopped at the red light and then flew on through it. Right? Stop. What do I mean stops? Technically, it would be a split-second stop. You would have to like do a super slow-mo to see that it actually stopped, in essence, right? And stops at what time? At t equals pi thirds. And then? And my little minus sign in the circle there looks like a theta. Then moves left. And you could, at this, the way you've worded this so far, you could say until t equals pi halves. Right? Remember those days, translating those? All right, let's go to B. B says, find the particle's displacement for the given time interval. Displacement. What is displacement? What did we decide yesterday? Courtesy of Zach's submission of that idea, right? It's S of B minus S of A. This is the general definition, right? So what I want for this problem is S of pi halves minus S of 0, right? Does the fact that we just wrote that tell us what we need?
Yes.
What do we need? Okay, so obviously, first of all, we have to have S of t, right? which would be the integral, and we're going to pull that 6 out front. Why? Because it's a constant, and that's what we do in calculus, yes? All right, and then it was sine 3t.
Would you not go ahead and put your limits of integration?
If you do, you don't want to call this s of t. If I want to write s of pi halves minus s of 0 equals, then I could do that. Okay? All right, so dt. There's only one correct way to take this integral, one technique, and what technique would that be? U sub. How do I know it's U sub? Because of that 3t on the inside, right? It's a composite trig function, right? So this is going to be...
Did you do sine t times 3t?
I definitely wrote that, but that's definitely not what I meant. I'm running on fumes right about now. There we go. We'll fix it. We'll make it emphatically 3t. Thank you, Mary Lindsay.
Why would you not do the integral of 0 to pi thirds and then pi thirds to pi halves?
Because we're looking for displacement. See, displacement doesn't care. Remember? And we talked about this back in particle motion, back in the day, first semester. But if I paced while I taught, and I walked back and forth, well, if you sat here and counted my steps, no worries, my Fitbit's doing that for me. But let's say my Fitbit says that by the time y'all left, I walked 112 steps. Okay? Am I 112 steps away from the podium? You see that? That's what that is. So displacement is literally at the end of the interval. So at let's say at 9:25, for some reason something in the room happened and somebody wanted to specifically say where I was, and you're like, I remember right where she was. She was standing right at this side of the Promethean board.
9:40.
I don't know. I haven't checked my email. My power went off during the night, and I woke up 45 minutes after I was supposed to wake up. So I'm pretty amped that I was here before 8. So I was like, I don't really care about anything else. I was like, because I was running around like a lunatic, and I was like, I'm still going to be after 8 getting there, and I managed to squeeze it down. So it's supposed to be at 9. So we'll see. But we won't. This isn't going to take much longer. We'll just do a couple examples, and then I'll check my email and try to warn y'all. But y'all know the drill, right? Literally. Grab a book to use as your helmet, because it's such a fashion statement. All right, so you good, Haney?
Yes, ma'am.
Okay. All right, so, but I need my S of t, which we're in the midst of finding here. So what's my U? U equals 3t. du equals 3 dt. So that means that, okay, it is technically 1/3 out front, and the smart way to do this is to not try to do it all in your head, deal with the fact that there's a 6 already there that has a 2 in it, or you can do it that way, just be careful. But the other way is just to stick a 3 under the 6.
Mr. Louis,
Yes.
when we're doing this, and it's like we have t squared and it becomes 2t, is that when we like just pull out the constant instead of like dividing it by 1/2? And we just pull out the 2 instead?
But you said we have t squared and then it's 2t.
I mean,
Oh, okay. So you're saying in the problems where the t was already there, like if I had t times sine of t squared, okay, and there's no 2. Well, is that what you're saying? Well, think about it. In that instance, and I'm gonna jump to another screen so I can actually write this. So what you're saying is if I had something like the sine t sine t squared dt, right? That's what you're saying. Okay. Well, in that instance, my t squared is my u, right? And my du is 2t dt, right? Well, I got the dt, I got the t. So when I write it this way, when I write sine u du, what am I implying is there that wasn't in the original problem? A 2. So to compensate for that, because there's a 2 in the du, do you see what I'm saying? That's what I'm saying. When I write du, I'm really saying 2t dt. So to account for the fact that I brought in that 2 that doesn't belong, I stick a 1/2 in front. So that's why on this one, we're sticking a 3 in front, because we're going to say that this is now sine u du, right? And what's that going to give me? 2 negative, so it's really negative 2, right? Cosine u. And we're not going to worry about the plus c because this is a definite integral, right? This just tells me what I need to write for my, and I'm going to jump back to this other screen and draw a line here. So this tells me that what I want for my s of pi halves minus my s of 0, I can now write it this way, is equal to, it's terrible s, the integral, wait, what was in front of our integral? A 3? Oh, 2. Yeah, negative 2. So negative 2 integral from 0 to pi halves of, if I keep the 0 in pi halves, that means I'm going to switch back. I don't know why I wrote integral. Why do I want the integral? Y'all should have stopped me. Stop me, people. Okay, brackets. Okay. Okay, and if I go cosine 3t, I'm going to keep the 0 pi halves. What do I do if I don't want to do that?
You have to do u.
Right, I would leave this as cosine u and then do u of my limits. So do it one way or the other. Okay, let me just demonstrate it. How about that? And I was trying to decide, I didn't really see a big problem with this on the test. I feel like y'all as a class probably did as well or better than that than any class I've taught before. But let's say I want to leave it in u. All right, well I can't just put, why can't I just put 0 and pi halves? Because those are values of t, so I have to use values of u. So I've just defined by this process that my u is what? 3t, right? So since u is 3t, when I write, and you can actually show it on this step as u of 0, and u of, and that's how you put it in your work, is you show it that way at some point. And if you don't want to write it in your work, then you definitely write it over to the side and change the limits when you go to u. Does that make sense? Like I said, I can't really remember anybody screwing that particular part up, but just in case, because I want to keep reviewing so we're ready for that diagnostic that you should be working on. All right?
Would it still be right if we
If you switch back to t's?
yeah.
Yes.
We put the-
Yeah, and so and we can go ahead and write, and I'm going to write it both ways, just to emphasize. Whichever way you choose, you just want to make sure your notation matches what you're doing. That's all I'm saying. All right? Because I think I did see one person who left it in terms of u, but then put the limits, I don't know, maybe there was some sloppy notation, but you wound up with the right answer or something. I feel like I remember something like that, but it wasn't. That usually happens kind of across the class more than it did with y'all. All right, so then this is going to be in terms of t what? Negative 2 cosine 3t from 0 to pi halves. You with me? So if I wanted to stay in u, my new limits then would be, what's the cosine of u? I mean cosine of, I'm not cosine. This is, what's 3 times 0? And why are we using that? Because that's what we defined our u to be, right? Okay, 3 times 0 is 0. 3 times pi halves is 3 pi halves, right? Simple enough? All right, so here we go. So I've got negative 2 times, what is the, well, first of all, what do I have to do now that I've switched back to t? What's the first thing I'm going to have to do anyway? So notice you're finding yourself in the same spot. All right, so pi halves is what? Now that I plug pi halves in, what do I have for my angle? 3 pi halves. Where is that?
Down here.
Straight down. What are the coordinates of the point down there? 0, negative 1, right? And cosine is which one? So it's 0. So it's going to be 0 minus, all right? Because, are you with me? All right? Because this is where it gets a little weird when you're doing trig. Because where you expect a 0, you're not going to get 0. All right? So, what next? If I put a 0 in, I've still got 0 inside the cosine, right? Which is 1. So my answer is 2. So the displacement, in essence, is 2. So in other words, this thing is 2, but it's positive 2.
meters.
Two meters per second.
No, it's just.
No, okay, okay, alright, what would be meters per second if that was our units in this problem? Velocity, so 2 meters, we're 2 meters in which direction? To the right of where we started. So the sign of the displacement tells you which direction you are from the starting point. Does that make sense?
So when we like write that, do we have to specify that like you're 2 meters to the right?
It depends on the wording of the problem.
Can you only go like up and down or left and right, or could you go like a curve?
But you're still gonna be.
Yes.
I'm sorry, say that again?
Like, can you only go like up and down or left and right, or could you go on like a curve? Or you could be like 3 meters to the right and 2 meters up.
We're gonna be on a line, because if you're on a curve, that introduces another variable. But the wording of the problem will tell you what you need to do. Does that make sense? It's not like you're gonna be like, oh, was I supposed to do that some other way? The wording of the problem will tell you how to interpret your numbers. I don't think I read all of B, because, well, and that's all that matters, because right now we found the displacement, right? I'm 2 meters to the right of wherever I started. Well, then it goes on to say, if S of 0 is 3, so on your paper you should write S of 0 equals 3 implies, and then I'm going to read you the rest of it, what is the particle's final position? The particle ends up at
2, 3,
5. S of, what would this be? Pi halves, right? Because that's the end of our interval. Pi halves equals 5. Because we were given that at t equals 0, the particle was at 3. So think like a number line. So the particle is sitting at 3 on the number line, and then it does something over the time span, but then at the end of the time span, the displacement is positive 2, which tells me whatever I did in that time span, what does that say? I ended up 2 steps to the right, right? Now that doesn't say that in that time span I didn't turn and run to the left for a few minutes and then come back, right? It only tells me where I ended up. You with me? Okay. So this is where we're going to account for, in part C, we're going to account for Haney's question, which was, why don't we have to break up our integral? Right? Okay. Now it says find the total distance traveled. Why is that a different question? Right. So that's kind of like my analogy I used to answer Haney's question, and that is, if I'm walking back and forth the whole time I'm talking, I might get in over 100 steps, right? But what matters for when it asks for displacement is where I ended up. But then now we're saying, how many total steps did you take? Well, that means I've got to count them going that way and this way. How do I count them? Do I let the positives be positives and the negatives be negative?
No.
Why not? Because what's that going to give me? Yeah, it's going to that's technically going to give you your net distance, which would be your displacement at some time, right? Does that make sense? Okay. So if I want my total distance traveled, and I want you to write those and underline them in your notes. That's how you know what we're about to do. Okay? Now, I'm going to see how on it you are to tell me how we would set up the appropriate integral statement that shows what we're about to do. Well, first of all, how do I get distance from a rate graph? The area, which is the integral, okay? Now, absolute value is great when you have a calculator to use, but this would be a no calculator problem. So what do I need to think about if I want to make sure that I compute this correctly?
Part after pi thirds needs to be positive.
That's right. The part after pi thirds has to be positive. So that means I don't have to do anything to the part before pi thirds, right? Because it's already positive. Okay, so tell me what to write to get that in. So we're going to put equals, because this equals my total distance.
Maybe the integral from 0 to pi thirds.
The integral from 0 to pi thirds. Is everybody with Mackie? All right, where'd the pi thirds come from? And we got that from our Dangram, right? Okay, so and what's my function? 6, so I'm gonna put the 6 out front.
Are we gonna start with the V and T, or could we just use the S and T? Since we are,
How are we gonna use the S and T?
isn't the S and T our f of x? And then if you find the integral of f of x, you get negative.
Yeah, but then we would have to take the integral of.
Yeah, but we're gonna write it from the integral step, and we can use the word, you talking about to compute it?
Yeah, like.
Well, we've already computed what the antiderivative of this function is.
Oh, we looking for antiderivative of this function, like of the velocity function.
Yes, because, and you answered my question a minute ago. I said, how do we figure out how far something's traveled? And you said you get the area, but maybe you didn't
But wouldn't that be
finish.
like-
The area under the rate function. The area under the rate function. Remember that thing y'all did last week? Those were graphs of the rate function. And y'all jumped right on the fact that the distance traveled is the area trapped between that curve and the x-axis, right? The area is your S when your graph is the V.
But wouldn't V be our first derivative
V is what we were given,
though? Oh.
right? And that's why I said, this is where you got to make sure you're really clear on what you have and where you need to go to get what you need.
Okay.
Yeah. All right. The only way I would take a derivative in this case is if I was asked something about acceleration from the velocity they gave me. But if they ask me about position, what do I have to do to the velocity to get position? Anybody? I got to integrate. Does that make sense? So now we're going to be working forward and backwards because we know more than we did when we first talked about particle motion. Does that make sense? Okay. All right. So then this is 6 sine 3t dt. All right. So I can keep that positive. Somebody who has not spoken today needs to tell me why I can keep that positive.
Because it's increasing on our diagrams.
Yeah. According to our Dangram, the particle was moving to the right on this interval, which tells us what about the graph? It's above the x-axis. Now we should know sine really well, okay? We should know it well enough to think about those function transformations and think that through without having to plug in numbers and whatnot. But let's just say we didn't do that, all right? I need to be able to do that for functions I don't understand, because you're going to have functions that are like crazy. And then you won't have any way of knowing. Sometimes they'll give you a picture of a function. You won't even know what the function is. And you've got to be able to do all this interpreting from a picture back to this. Then they may say the region of area A, of marked A, is 7, and the region B is -3, or 3, because it'll be below the x-axis, and that'll be on you to realize that should be negative, that sort of thing. You with me? So you want to be able to abstractly interpret. That's why I'm making a big deal about this. All right. So since the velocity graph was above the x-axis, and we knew that because the velocity itself was positive on that interval. Does that make sense? Okay. So what should I do next? And I have options. I can subtract. I could do plus a negative. Is that what you said?
Yeah.
That's an option.
You can do that.
Or I could do the absolute value of the second piece. And even though I'm not technically going to be taking the absolute value in terms of my head, and maybe inside my head, that's how you note it on paper, okay? So pick your favorite and write that. All right, I'm going to do minus.
You could just double that too.
Well, you could double it as long as you had a full cycle, as long as you had symmetry there. But you got to make sure you have that symmetry there before you do that, okay? But it's a very good question. Yes, you can use symmetry. That's a very big idea we're going to wrap our heads around in this chapter, is using symmetry. All right, so now what do I put? Pi thirds to pi halves of sine 3t dt. Now, notice something here. The fact that I wrote this statement doesn't mean that I'm going to forget I did part B. This is just my notation to demonstrate that I'm already aware that I can't just take the integral of the whole interval. Okay? So then, on this next step, I can write equals 6, and I'm going to do big parenthesis, and inside there I'm going to put little brackets here. All right? And I'm going to do this as cosine u. I'm going to switch it back because I did it the other way on the other one. Now, I'm not saying you should switch back and forth. I'm just saying that I'm showing you how you could do it either way. All right? And remember, our lower limit was 0, right? Yes.
Would it be -2? Yes.
Yeah, up front.
Oh, my bad. Thanks. Appreciate that. It's especially hard when I'm on one little screen and don't see all the information. That's why I keep asking y'all rather than having to go back and look. All right. So we have a -2 out front. So my limits of integration, if I'm in U, are 0 and 3 pi halves. I'm just seeing if y'all are paying attention. Come on, stay with me here. All right, so that takes care of the first one, right? Or does it?
That's the whole thing.
That's going to be my upper limit, right?
Yeah.
Like in the other one.
So it's just pi.
So this is just pi. And then minus, right? Okay, and I'm going to have another little box, cosine u from pi. That's the nice thing, because I'm picking up where I left off from the last one. I don't have to rethink that. 3 pi halves. There's your 3 pi halves. You with me? There you go. All right. And again, maybe I don't need to write this. I can kind of do this in my head sort of, or jump that step. Well, this step is not about what I need. This is about showing where the next step comes from to the person who won't necessarily be following what I'm doing. This demonstrates that I understand the proper notation and whatnot. All right, so -2, parentheses, all right. Then I'm going to have, what's the first thing I'm going to have? Cosine of pi. And you should probably write this step too. And you might think you don't need to, but I promise you, your trig is not where it should be. And the more you put on the paper about the trig stuff, the better chance you have of getting it right. Minus what? Cosine of 0. And then minus, and I'm going to put these parentheses in a special color because we seem to still be having issues with distributing negatives. Y'all aren't as bad as some classes I've had, but there's a few of you that are still struggling with that. All right? As demonstrated by your parts problem on the test. So what will I write inside here? Cosine of 3 pi halves minus the cosine of pi. And then I'm going to close my green parentheses here. Come back to my blue. And bracket. Or no, big parenthesis. I didn't switch colors, did I? I thought I did. Big parenthesis. There we go. So I've written all of what I'm going to do. So then -2, what's cosine of pi? -1. Cosine of 0? 1. And then I'm going to distribute as I go here. So minus, what's the cosine of 3 pi halves? 0. And then I'm going to minus, so I'm going to plus. Right? What's the cosine of pi? 1. -1. Right? Because I added a -1. You with me? That was a lot of negatives to account for. All right? That's why if you don't write this stuff out, you can lose that answer off of that one little sign, because there was 2 minuses and a negative to account for on that one number. All right? And then you'll be like, why did I get the wrong answer? I thought I did it right. You probably did. You just blew the arithmetic. All right? Well, then I can obviously ignore the first and last terms inside the parentheses because -1 and no, I can't, can I? Because I got 3 -1s. So what do I have? -3 times -2, 6. And what was the question here? Total distance. Okay? So between 0 and pi halves, the particle traveled 6 meters. Yeah, it does say meters per second. I guess I didn't remember reading that yesterday. All right. Do y'all feel like you have enough to jump in at this point and then see where we go? Because I think you. I mean, do you see how I'm saying like most of what we did that required thought was stuff we had done before? The only new part of this is the fact that you're going to be given information. You might, and somewhere in this assignment, you will be given acceleration and asked about position. Okay. Yeah. So you have to integrate twice to get back to your position. Yes, Clark.
Do you have an assignment sheet?
You do. I handed it to you.